So let's continue looking at our environment, our Xen environment. So we have our first node up. It's bound to a small fraction of our LVM space via this logical volume named dev xenvol1 ubuntu guest 1, of which we're using a small percentage, maybe 12%, 12.5%, 8 of 100 gigs. It's very tiny compared to the overall space. So that leaves us room, of course, to provision many other VMs, and we know that we can interact with our DOM-U, guess, or VM, interchangeable terms, of course, using VNC. We may also interact with it using a console. Some changes need to be made for HVM guests to make that happen, especially with the case of Linux. It's quite possible, since Linux servers come up with TTYs that are shell-based, so you can place it on a console, but perhaps the easiest administrative tool is VNC. So now that we've got one DOM-U going, let's have a look at maybe management via XM. So management via XM. Now, there are many means with which you may manage your DOM-Us or XM Xen instances using XM and other tools, etc. So there are many means, but XM is the common tool, and it's included. So various tools are available, certainly, both GUI as well as shell. But what's included with Xen across mixed systems is XM. So XM is primary management tool. And it can be used to do a variety of things, such as gathering details, firing up and down the host, suspending it, resuming, pausing, unpausing, etc. Those are key features because it allows us to manipulate the resources real time. So for example, to gather basic details, we've already looked at some of the simple options, and we'll look at them quickly again. So for example, XM list lists details pertaining to the various DOM-Us as well as DOM0, and that gives us basic information. XM with no options show us the options that are available. And XM, let's say, with a particular option, so let's say XM list help configuration, for example, shows you additional options. So include that as well. And that'll be maybe XM list help config enumerates all options. So if you want more details concerning your DOMs, you may use the long option, for example. So, or maybe the parsing of DOMs by particular states, for example, show me all DOMs that are in the running state, so state equals R, for example. So XM list will show us details pertaining to the various DOMs. Now it looks a bit cryptic, but this is the SXP format that's read by Xen. If you pipe it to, let's say, less and have a brief look as it goes through, it shows you the various DOMs beginning with DOM0 and the configuration associated with the DOMs. Let's get past the CPU and you'll see momentarily. And those are individual instances associated with the CPU. So the behavior of various features that may impact your DOMs, such as what happens if Xen is powered off, or the system Xen is powered off, or Xen stops, should we power off on, or when it receives a power off message, that is, should we destroy the instance? If it crashes, should we restart it, or maybe allow it to remain in a crash state? And identifiers such as UUID, the name associated with it. What happens when a reboot message is sent, the system is restarted? What is the max amount of memory the DOM should be allowed to use? The amount of memory in usage. What happens when XenD starts? Should it ignore? Should it maybe start up? Maybe shut down because of some weird configuration condition that your environment requires? What happens when XenD stops? Now, what's the importance of XenD or XenDaemon? Well, XenDaemon's behind the scenes, and it allows the passage of messages between the client, let's say XM and others like XL, and maybe even the GUI tools such as the virtual manager or virt manager, and the server Xen. So you're able to pass messages into the Xen environment, which allow you to further communicate with each of the nodes by effecting certain actions, such as restart, stop, or shut down, in other words. Pause, unpause. Maybe up the available memory dynamically or elastically provide more memory, more storage, more CPUs, or fewer of the aforementioned. So those are some of the states that you see associated with it. Now it moves on to the next domain. The current ID is 7. As we've mentioned, the IDs are applied in an incremental fashion by default. You can force IDs to particular Xen domains if you'd like. Just check the documentation. In the event that your scripts rely upon it, perhaps you manage domains by consulting a database which has hardwired IDs, but to be safe, for uniqueness, you should reference always the name of the domain as opposed to the ID, because the ID certainly changes by default. So DOM ID 7, particular weight, number of CPUs, if any particular bootloader. Now, remember, Xen supports both HVM as well as PV means of provisioning virtual machines or DOM user guests. So you'll see some options that appear to be either commented or inactive or disabled. And that's fine, such as the kernel, the bootloader, and others, maybe features, etc., description. Some are important, others, or some are just metadata, such as description, others are important. So for example, bootloader and kernel in the case of PV or paravirtualize DOM-U would be important. These two variables indicate where the DOM-U would inherit its kernel and init RAM disk and other options associated with making that DOM-U come to life, if you will. So for this DOM or DOM-U, what happens when Xen starts or stops? The default is to ignore in both cases. So what this means is the DOM-U has no regard for Xend. Whether or not Xend is available is besides the point. So long as it's running using resources behind the scenes, it should be accessible using standard TCP/IP communications. Which means, of course, your client tools such as XM may break down from time to time if Xen stops, but Xen stopping will not stop default domains or DOM-Us from continuing. So note, default behavior is to ignore the state of XenD, which is good. This is what you'd prefer for most environments. So you may have a tool breakdown, a client breakdown, but it's not a problem. So this is an HVM image, the amount of CPU time it's used, when it was started, number of seconds, epoch time, the options that we've passed in. And by indicating a build of HVM, it defaults to using the HVM loader. And the HVM loader is that emulated environment which provides, of course, the BIOS and familiar environment to the operating system so it believes it's on physical hardware. Shows the current status, the unique MAC address assigned to the virtual interface. That's going to be VIF70. Each interface will, of course, wear a unique MAC address, 48-bit address. And the script that's used to bridge this particular virtual interface onto Ethernet 0. In etc Xen, there's a scripts directory, one of which is the bridge script, which facilitates the bridging of, again, virtual interfaces to the DOM0's interface. So it happens when you fire the node up. That's all part of it. It presents it. A console for the node to use VT100 and where it points to. Again, there's constant communications back-end, front-end between the domain, the DOM-U, and the DOM0, which has actual access to the device. So for example, the virtual keyboard, console, VT100, its location, and that's where you can connect to it on if you make the ties, etc. The virtual backend for the disk, this is a block device, virtual backend for the block device, has a unique ID, 64-bit. It's a hard drive, and it points to this location, which is provisioned by LVM. So as long as your underlying LVM is working, which can raise a problem, of course, in the event that you notice that your DOM, one or more of your DOM-Us are having problems starting, then perhaps there's a problem with your underlying LVM configuration. Maybe there's a disk issue, maybe LVM failed to start because of various issues, so something you'd want to consult. Virtual block device for CD-ROM access is still this ISO image, although it's currently not being used to boot the system, and some other options that we've placed in, such as the virtual frame buffer. These are the options we placed in, and it defaults to all IP addresses and any unused port, which is the VNC unused option of 1. And every object is represented with a UUID. So that gives you the long listing, but rather than go into much more details about that, let's look at some other options. So you've got XenVM. XenVM lists details concerning X or Xen altogether, its resources available, the kernel that's using, whether or not it's up or running, the version of the configuration file, as well as some other items. XM uptime is just like uptime as we've mentioned, but now it shows you a list of DOMs, including the base DOM, DOM0, and additional DOM-Us, such as in this case ID 7. So it shows the amount of time that that DOM has been up, and you should be able to follow it. It's certainly been running for a bit, 17 hours in one case, 25 minutes in the other case. As we've already shown you, XM top or Xen top, either or, will pull the same information and you'll see the usage. So in this case, DOM0 is using more resources CPU-wise, or memrise in this case. And CPU-wise, it seems as if they're both not doing much, which is fine. That means we're not overwhelming the resources associated with the system. Just consult the XM options to see what might be applicable. So you've got, for example, XenVM, XM uptime. Another one that comes to mind is XM DOM state. So return, let's say, the current state of a particular DOM or domain that is a DOM-U. So XM DOM state and the number of the domain or name if it's readily available. So we know the DOM IDs are present. We'll just do a DOM state 7, and it tells you what DOM is doing. It's currently idle, not doing much. DOM0 is treated specifically, or especially that is, so it doesn't return much specifics in terms of its current state. Although there are some cases where it returns information if it's extremely busy. So DOM ID 7, which is Ubuntu Guest 1, is idle. It isn't really running many processes or overwhelming the CPU. Certainly that would change if we ran something. Many other options exist, including the ability to connect to, let's say, the console via VNC or via the console option for PV hosts. So for example, you could use, let's say, XM VNC viewer if you happen to be logged into the Xen host, followed by the num or the DOM name. This is an easy method of connecting via VNC because it auto-calculates or derives VNC IP information. So rather than doing what we've been doing, which is VNCing into a particular host name and a particular port optionally as you launch new DOM-Us, XM VNC Viewer does it for you. So how do you see those effects? Well, one way is you could SSH into the remote system and send back the X11 calls. So for example, if you SSH X into the server, let's say, maybe as root into LCBT Ubu VM1 from this particular host, that gives us a session. And it doesn't actually have the X authority. We haven't set up an X environment on the remote system. So if you try to, let's say, do XM, and let's see if we've even got VNC Viewer. We don't have that there. So if you try to run any command that requires a GUI, such as XM VNC Viewer, we haven't set up the environment, nor do we necessarily want to. But let's say we try to connect to 7. It tries to start, the VNC Viewer is not available. So what if we did an aptitude install VNC Viewer? Now, X is not required in order to send back graphics. Usually you just need to have the appropriate files such as X authority, as well as the appropriate application available in order for it to work. But if you want to keep your server free of additional graphics-related resources, then maybe the better way of connecting is just knowing the IP addresses associated with and ports associated with the target system and try it that way. But let's try it this way. And notice it throws an error. Now this could be an X authority issue. Probably have to double check our default directory. Actually it came up in this case, so maybe it was just the first time. So in this case it worked. So it actually should have created the X authority. Let's take a look. And it created it for us, X authority. So we no longer need to create that. So this actually worked in this case. So let's say we SSH x to Xen hosts, followed by an XenVM viewer, followed by the DOM name or its number. And this exports VNC session back to local system. And providing, of course, VNC viewer is installed, which we just quickly did. So that brings it up. And again, it's faster because we need not know where the DOM-U is bound. And it gives us that window, so we can do it by ID or, let's say, name, which is a bit longer, but still works because Xen will take care of finding it for us. And we can, of course, interact with the remote system as we would otherwise. There would be no problems working. And to enable root, we'd have to do a sudo password for root, setting root's password to something other than the default of not being set to allow the SSH connection for the user root. So now if we drop, we should be able to try it again. Let's wait for this to cycle. And if you search online, you'll see all of the various tricks for sending commands to VNC to allow you to be able to access the various consoles. Certainly, we're defaulting to TTY1 here, but now we have a root access on that remote system. Let's just make sure some packets can still go out. And we'll try to hit default gateway, and that looks good. Now let's see what else we can do instead of getting into some basics concerning VNC. Of course, you can use VNC viewer as we've already done. There's XenTop, which gives you information about, or XMTop, about the usage of each of your DOM-Us. So XMTop or XenTop. You'll find that there's a counterpart on the Xen side for XM commands as well. So returns top like usage information per DOM, including the DOM0 itself. Now, what about state management? So, regarding state, a number of options are available to us. The ability to say, perhaps we'll just label this separately. So, state management. So, a number of things you can do here. Sometimes you may need to stop or shut down, or maybe reboot, or pause or unpause. Suspend or resume, or destroy domains altogether. How are these options useful to us? Why and when do we need them? So starting is obvious. If a domain's down, you need to start it. If a domain's up and you need to shut it, then you can, of course, obviously XM shut down. That'll shut the remote system. So XM list shows you the various states. XM DOM state for a particular ID shows you the state of that item. Shutting it down is simply XM shutdown, the DOM ID, and that'll show you on the console until it closes the current state, meaning the init process, in this case 0. And let's take a 7, doesn't exist. Let's do a DOM state Ubuntu guest 1, since that doesn't, nothing's there, or that should be guest with a T, so let's try it again. It's currently shut off, and that's more like it, so let's do an XM list. So the domain's down, no problems there. You can shut it down just using XM, and let's go back to our history, shut down and the ID or the number. So XM shutdown num or DOM name. Rather straightforward, but this does a graceful, so graceful shutdown, which basically initiates an init, or it's as if you've pressed power, soft power, to power off on the console or on the physical machine, which results in an init 0, whereby the services are shut in the appropriate sequence, which ensures that the hard drive is properly demounted and so on and so forth, dismounted and so on and so forth. So this is perhaps a safe way to shut a system, but sometimes it's not quite possible to do it this way. Sometimes you need to shut a host immediately, and of course there's an option for that as well, such as XM destroy. So let's say we XM start the name, and this will fire it up rather quickly. So fires up node or guest, and no surprises there. So XM, let's say start Ubuntu guest 1. And we can quickly connect to it, let's say using You could even actually tell it to do the VNC viewer in there at the same time. And this will bring up a window. Now it'll lose context as it comes up, so you'll lose the screen as resolution shifts. But this will bring the node up rather quickly. And then sometimes if a node's up and you need to quickly bring it down, you need to destroy it. So let's put this into that window over there in that space over there. So another option is XM destroy num, or of course DOM name. This is an immediate termination of guest or DOM-U. So in scenarios where it is apropos for you to terminate the node quickly without regard for the state of data, let's say your databases, file systems, etc., then destroy is an option that might be useful or applicable. It's certainly not recommended, but sometimes is simply necessary. So this is coming up. We currently have no control. Let's see what it's doing. We'll try to reconnect. It's probably not recognized that it's lost state. It's actually still coming up. It's been slow to come up. There might be some debugs that we can do to speed this up or expedite it. Now it's going to do a context shift as it looks to load the Linux kernel and momentarily come up. So destroy will terminate it rather quickly, so we've lost our state there. That'll bring this up, and we should have a login screen soon. That's about a 2-minute boot or so. Not so bad, considering that it's sharing resources with another node, so it could be slower. So now it's back up. And from any of these systems, we should be able to send some packets, presuming that the same IP address persists. So 7550, just make sure in both directions you can get to it. That looks good so far. So let's try to see what ports are open on that remote system. 7550. Perhaps SSH comes back. We'll see what it comes up with. We did tell it SSH, open SSH and LAMP, so at a minimum we should see LAMP-related, SSH-related packets. So sometimes the server needs to be killed immediately, as we've mentioned. So XMList is going to show a new DOM ID. Of course, begs the question, if we restart Xen, would we recycle the IDs? But of course, XM destroy does that for us as well. So destroy 8, this kills it immediately. Notice the VMC window disappeared. And now it's dead. The resources have been returned to the primary system, and of which we have that much free. So it's gone. And what happens to the state? So now if you start it, it's going to start from scratch where it did before. So let's do XM start. So it didn't pause. It didn't suspend. Let's start Ubuntu guest 1. And let's try to connect from here. Ubuntu guest 1. So it's back to scratch. So it's just a faster way of terminating the node. Again, XM destroy, immediate termination, non-graceful, possibly dangerous method of termination. Let's say concerning disk I/O. So let's say IE databases, file systems, etc. But sometimes it is necessary. One scenario that comes to mind, let's say one of your DOM-Us has a runaway process and is consuming the majority or the bulk of the resources available to all of your DOM-Us and DOM0 itself. So that may be a means or a justified scenario for destroying a node. You do have the ability, of course, to pause and unpause, suspend and resume. So let's say we have a quick look. XM, maybe pause, unpause the name or the DOM ID and see how the behavior impacts. Let's do a DOM name here. So let's see where we are. This should be back up because we lost context, and it's actually close, so it should be there. So, and oftentimes after post-destroy, of course, you'll find FSCK will attempt to check the file system in search of problems, which could cause a delayed boot up. So now XM list should show newly assigned ID. It's out to 9. It's available. We should be able to send some packets. Let's do a ping. It still comes up as 50. DHCP is still working as expected. And simply XM pause DOM ID 9. And XM list should show that it's in a pause state. And now the node is no longer accessible. If you try to send some information to it, it doesn't respond. And if you try to send some packets, let's send some to 50, it doesn't respond as well. And let's resume it. So the opposite of pause is unpause. And again, all hypervisors have this, whether VMware, VirtualBox, KVM, Xen, the major ones. So XM unpause, rather straightforward again. Number 9. Now when you pause, the ID still persists, unlike with destroy or shutdown. So I'll unpause it, shifting the state, of course, from pause to either B or R, and then we should then be able to send some packets to it. And then let's see what happens to this VNC session. And as you can see, it took the keystrokes, and now it allows us to connect back as well. Now, how does this impact the overall system with respect to the programs that we're running? So let's get something running. We'll run top. That's running. Now let's pause it again, and let's see how that behaves. That's going to be in number 9. So let's see what's happening with top. So top is currently frozen at 99.5% idle. And let's see. If we unpause it, we should see momentarily that it shifts. So the process keeps running when you pause, unpause. What happens if you try maybe what seems to be related, functions that are seemingly related, such as suspend, resume? So suspend, resume, seemingly related functions, dom name, num. So let's say running processes persist when you pause. Persist in the sense that the state is maintained, and you'll lose some state between when you pause and unpause, but the processes, the state table or the process table, the entries that are inside that table continue to persist. So let's XM suspend 9, and now that it's suspended, let's take a look to see what's going on here. So as you can see, we're not getting any updated information. I'm waiting for this to come back. Let's do an XM list. We actually broke it. So now it's in a suspended state, and it reads migrating because, of course, it's migrating it to that state. Let's do an XM on, or in this case, resume. Not pause on pause, but resume 9. And error occurred, resuming already exists. Let's take a look. It's because it's still migrating it. We actually broke the process, but it should eventually ultimately migrate it. So suspension and resumption will freeze just as you would expect, as is the case, let's say, with suspending your laptop or suspending a VMware instance. They behave in similar ways. Now, we'll let this go for a little bit. It's taking a little bit. It might actually be frozen, and in which case we may need to destroy it and bring the instance back up altogether. But again, suspension, resumption will allow you to release the resources and to stop the processes that were currently in the process table, such that they are not at the same state when they resume. So for example, a simple program such as keeping the time in sync on the Linux node will not be updated in the event of suspension and resumption, unlike with pause and unpause. So when you pause, the time keeps on ticking, but when you suspend, it doesn't. And that's why you'll notice time changes when you suspend and resume these nodes. Let's see what's happening here, if it's changed any. So now it shows that it's suspended. So suspended is like shutting the system off. So let's XM resume Ubuntu guess 1, thereby, of course, releasing the resources. So what's the advantage? Well, you avoid the whole boot up sequence, which in a fast Xen environment doesn't take too long. However, it still saves you some time. So this is trying to resume it, no differently than flipping open VMware and resuming a particular instance, and it saves you time from the overall boot process altogether. Let's do an XM list, and it should show. So it's in multiple states now because it's coming out of that state. And actually, it's now out of that state. Let's do an XM list again. And momentarily, it'll show B. And then we should be able to connect to it, Ubuntu guess 1. And now we see it booting up. So there must have been an error with the suspension of the node, causing it to have to reboot from the beginning. So because we broke it, the XM suspend, that it simply just shut the machine off altogether. So we'll just let it boot back up altogether. Now, other options exist, such as snapshots, which allow you to name the state file, as opposed to having one automatically defined for you using suspend. So that's a means with which you can create the target system as well, or the target file for the system as well. So snapshots permit the naming of, let's say, target state files. You just use the save, so XM save and restore options, of course indicating the file name, so target file. And let's just note works like suspend, resume. The important thing with the snapshot option is that when you snapshot a system, when you save a system, you dump its usage of system resources, so memory, CPU, to the hard drive, such that the resources are freed for other usage by other domains or DOM use. And many other options like what to do when the system's powered off or rebooted, or if XenD is started or stopped, etc., or additional options that allow you to influence the states associated with your DOM use. So that's a little bit about XM management. There are other tools, XL, Xen and XM are synonymous, and GUI-based tools for the management of these Xen instances.